All right, so a little bit before we start, like we were talking about earlier, this is a Tartan Hacks event. Come on in. This is the first of the crash courses associated with Tartan Hacks 2012, where we're basically trying to take you from sort of knowing what's going on to knowing enough to figure out the rest in terms of building a web application, making something really cool. This is the first time we've ever done this. There may be some glitches, some flaws, some blatant typos, although I don't think there are any in this one. We'll see. And hopefully you guys can learn something. If you have any questions, feel free to just shout at me. My glasses broke the other day, and they kind of do this now. So if they fall off my face, I might just keep talking and not be able to see you, so just shout at me. And oh, he didn't know. Yeah, they're just like, woo. They're actually held together with heat shrink right now. So yeah, I'm going to get started. You're probably here for one of two reasons, or maybe three reasons. One, you thought we were going to be giving you food and wanted that, and just figured you'd sit through a talk and get some food. We don't have any food, sorry. Two, you really like the sound of my voice, which most of you haven't met me before, so I don't think that's it. Or three, you want to know kind of what a web app is and like what this whole magical thing is. So here's the basic idea. There's you, there's some information that you want to mess with, and there's this thing in the middle. It's called a web app, and it's this magical cloud, and it's magic. And you say, okay, well, magic isn't good. Magic doesn't really explain anything, so what's really going on? What happens is you tell your browser to get a website. It goes, looks up where the website is, goes through the internet, finds the server, tells the server what website it wants and what page it wants and what everything it wants. The server does all kinds of different magic. It gets the information, then it shoots it all back to you through the internet and displays it in this magical thing. Got it? No. You probably have no idea what I just said, and you're thinking, what is he talking about? Why is he talking? I don't want to be here. That's OK. So let's start with a definition. This is the definition of a web app, or a web application, from Wikipedia. It is. A web application is an application that is accessed over a network such as the internet or an intranet. The term may also mean a computer software application that is coded in browser-supported language, such as JavaScript, combined with a browser-rendered markup language like HTML, and reliant on a common web browser to render the application executable. That's from Wikipedia. There are a lot of words there, and most of them you don't need to know about, so let's focus on the important ones. These are the important ones. It's an application, blah, 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 accessed over, blah, 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 the internet, blah, 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 there's JavaScript involved, blah, 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 HTML. These are the important words from that definition. So lots of words, important words. If only we could do textbooks like this, that'd be great. So there's a bunch of different parts here. There's the application part, the internet part, JavaScript part, HTML part. If you can understand basically those four things, you can understand what a web app is doing. So an application, what is an application? You can ask 100 people that, and they'll all tell you something different. And if you try and figure out like the commonalities between what they've told you, you'll get nothing. You'll get nowhere. An application is basically a word that people use to describe some way of interfacing with information on your computer, and that's it. There's really no commonly accepted definition, and even if there was, it wouldn't make any sense. So there's basically three parts. There's actually interacting with you, the user. There's processing information that's stored on your computer or somewhere else. And then there's displaying that information back to you in a way that you can make sense of it and then continue interacting with it. And it sort of goes in this loop. So for a web app, you start with something called your browser. That's like Firefox, Chrome, Safari, Internet Explorer, Mosaic, whatever you want to use. Don't use Mosaic. It doesn't work anymore. And what happens is the browser will get something called HTML, usually. There are other things the browsers can display. Most of the internet is in a form called HTML. And HTML is just a way of encoding a web page. And the information in the HTML can say, OK, well, here's what the web page looks like. And by the way, you're going to need all this other stuff, too. So we'll get to more on that in a second. HTML. It stands for Hypertext Markup Language. It's been around for quite a while. I didn't actually look up the date, but it's really old. And basically what it is just human-readable text. You can open up Notepad or your favorite word processor if you really want, or your favorite text editor, whatever, and you can type in some text that you can read. And as long as it's structured in a way that the web browser can figure out what it is, it'll display it like a web page. So here's a simple very basic HTML document for people that have never seen it. And we'll cover HTML in tomorrow's talk, Bowen's tomorrow night, and I'll have more information on those later. But here's just sort of a basic overview of what's going on. There's this sort of thing, and there's some header stuff, and there's some body stuff, and this is where what most of the user sees happens, and then it kind of closes. So what you'll notice are these things called tags. They're between these angly brackets, and they're basically control things for the web browser. So you'll have a tag, and then after that tag is all the stuff that goes inside that tag, and then later it gets closed. So this is the HTML document with the HTML tag, and then it closes with the HTML tag, that's the closing tag. And then inside there's the head tag for header, and then some stuff, and the header ends, and the body of the web page starts, and the body ends. You don't need to really know all this. You can look it up if you ever are writing HTML by hand. Most of you probably will at some point, but not regularly. And then there's other stuff. You'll notice that some websites have pictures. Some websites have colors. Some websites have exciting text. Some websites have text that bounces across the screen in all kinds of fun ways. Those are all just more tags. So if you wanted to have an image tag or an image in your website, you put an image tag. Text formatting, these are actually, I was told earlier, out of date. When I learned HTML, this was how you made text bold and italic. Apparently things have changed in the last decade. Oh well. But this is sort of the idea. You still use tags. Now it's EM for emphasis and strong for strong, or maybe it's the other way around, for different text formatting. If you want to have a script, which again, more on that later, it's basically a way of making your website interactive-ish. You can just put in a script tag and then dump some script in and then close the script tag and move on with your website. Hyperlinks, a link to another website, you use the A tag, obviously, for a hyperlink. It stands for anchor. There's other things you can do with it, too. Styles, again, more on that later. But basically, it's a way of making your website pretty and sort of divorcing what the website says from what it looks like. And apparently, there's also a style tag now. Again, things have changed in the last 10 years. So sorry, this is out of date. Don't use this as a resource. We'll have real stuff for you tomorrow. So the good news about HTML. Basically, everything in an HTML document is optional. You can leave out the opening and closing HTML tags. It'll still work. You can leave out the header. It'll still work. You can leave out the body tags and just start dumping information in, and it'll still work. And it's really, really simple. If you want, you can just take your favorite text editor, open it up, and just dump some stuff in, save it, and open it in your web browser, and it'll show up. It'll be a web page. It's actually kind of fun, and that's the reason I'm into computers. It's a long story, but this is where I started, and it's a good place to start. It's really easy. There's tons and tons of documentation. The bad news. You'll notice there's a lot more text on this slide. HTML by itself is really boring. You can't really make anything that looks like anything that anyone would ever want to look at without a style sheet, without some script, without some images. You can do it without the images. There are ways to do it. It's not impossible, but it will make web developers cry. And I'm sure that Ryan can attest to that. Yeah. And there are better ways to do it. You can use styles, you can use scripts, whatever. HTML is tedious. If we go back to what this looks like, right here, if we rendered this, it would say a single sentence. The content of your page goes here. That's all that would show up for whatever this is, 10 lines of HTML code. It's not exactly the shortest language. If you want to write it all by hand, and then when you want to update the content, go back and change it later, it would be a huge hassle. And if you don't want to maintain it, if you leave the company and go work for someone else, or if you die and someone wants to come into your place, or if the person before you dies and then you have to come maintain their code, it would be impossible. It would just be like ridiculous. And then lastly, HTML is static, which means it doesn't change. It doesn't change itself. It's basically just a document, and it's posted somewhere. And when your browser goes to find it, it's the same thing every time. It never changes. And if you want to, I have the example, post a dissertation about your cat. You can use HTML for that. You can make this beautiful document that's all about your cat, that has all these pictures and exciting information and like a big thesis about why your cat is the best thing ever. But if you want to make something that someone might actually use at some point, or might actually want to look at, or might be interesting to more than your grandmother, you need more than just HTML. So the good news is we can solve all those problems. The bad news is we do it by doing something other than HTML. We can solve the boringness with something called CSS, or custom style sheets, where basically, like I said, you take HTML for the content of your page, and you say, OK, well, this is a list, and this is a header, and this is a paragraph, and this is all this other stuff. And you just use your HTML to say that. And then you make another separate document that says, OK, a header looks like this, paragraphs look like this, all this other stuff looks like this, links are this color, text is this color, the background is this color, and then you just link them together. And suddenly your website is really pretty, and it's really easy to change stuff, and everything is wonderful. It's actually a language that's designed more or less exclusively to make HTML pretty. It has no other purpose. And it's really, really pretty nice. And it's also just plain text that you dump into a file somewhere, and your browser goes and finds it. JavaScript. You can use JavaScript to make your HTML somewhat interactive. Depending on your definition of interactivity, it's a little hand-wavy there. But you can use JavaScript as sort of like when you click on something. If you click on a link, it doesn't necessarily have to go to another page. It could open a pop-up, or it could send your credit card number to my servers, or something. You know, whatever you want the website to do. And then the last thing, the other thing with JavaScript, you learn it for something like web, and you can use it for anything. Like, JavaScript is everywhere. It's ridiculous. You can program like phone applications in JavaScript, and no one even knows. It's insane. And then lastly, the staticness. Like I said, HTML doesn't ever change. It's really boring. But if we want to understand why that is and what we can do about it, we're going to have to tell a little bit of a story. So I give you the tale of the tale of an HTTP request. How about that? So there are two heroes in our story. There's the wise old king, who is like me, or yeah, let's go with me. And then there's the brave knight, Sir Browser. And the king says, "Brave Sir Browser, please fetch me the finest Google.com homepage in all the land." And Sir Browser says, "Yes, my liege, I will do that." So Sir Browser rides to the wonderful far-off land of Google.com and says, "Hail, Google.com, here's where I'm coming from. Can you help me out?" And Google says, "Yeah, sure." And it'll give you this web page. And then the browser brings it back and says, "My liege, I found it. It's an HTML document, and it looks like this. Here you go." And I say, "Yay, now I can find cat pictures." Because, you know, that's what you use Google for. I can't really think of anything else. Just funny cat pictures. The end. That's the story. So what happened? There's the user, me, who asked the browser, played by that ridiculous drawing of a man on a horse. And I said, "I want a web page." So the browser will go out and find the server and tell the server a lot of stuff. It tells the server where it's coming from. It tells the server what kind of browser it is. It tells the server if it's a mobile application or not. It tells the server all kinds of different things. And how many of you have ever heard of a cookie? Yeah. The web browser will tell the server any cookies that it has for that server. So if I go to Google and Google remembers who I am, it'll send my web browser a cookie and say, "Hey, remember this." And next time my web browser goes to Google, it'll say, "Oh, by the way, you told me to remember this here." And that's how websites can keep track of who you are and fill in a lot of information for you and generally keep tabs on your life. And then what will happen is, once the server knows who we are and what we want, it does something. And then at the end of the something, it spits some stuff out, and it tells the browser what kind of stuff it is, and the browser will show that stuff to me. So stuff. What kind of stuff? The browser and the server are talking in a language called HTTP, which obviously goes something like this. And HTTP stands for Hypertext Transfer Protocol, which you will never, ever need to know. And usually what it is, "Hi, server. I'm a browser. Here's my life story. Here's everything you might possibly want to know about me. Can I please have this page?" And then the server will say, "Sure. Here's the page." And then it will just dump HTML at the browser. And the browser will take that, and it'll figure out what it needs to do. If you remember, HTML can have stuff in it, so it'll get all that good stuff. And the browser will say, "OK, well, this says there's an image here. So server, I need that image." And the server will just start dumping the image at it. And then it'll say, "I see there's a style sheet here. Server, I need that style sheet." And it'll just dump the style sheet. And the browser will just automatically make all these requests to the server and get everything it needs and then show the website. So the server does something. You'll remember this bolded something, you know, because computers are magic. There's some more magic there. So what's the magic? Here's the magic. The server is just any program that can output HTML. Any program that can speak HTTP can be a web server. So yeah, you could write a program in Ruby, like you did in 110, and that could be a web server. Anything that can listen to a browser and then dump out information, it can be a web server. Even if your program just says, it listens to the browser and then ignores what it says and dumps out a web page that shows a picture of a cat. That is a perfectly valid web server, for some definition of valid. It would work. You could point your browser at it, and it would work just fine. You would get a picture of a cat every time, no matter what you asked it for. It would be the best website ever. So a web server is really just a program that can respond to browser requests. And that's all it is. You could write your own every time for every application you ever wanted to do if you really wanted to. That would be horrible. So there are some common things like telling the browser that it's dumb if it says something dumb, or running a program to generate dynamic content. I'll get to that in a second. Or finding static content, which is sort of going and digging up a web page from the archives and handing it to the browser. And then doing all that really, really quickly, because computers are fast, faster than people. And when we click a button, we want it to show up instantly, whatever it is, even if that's impossible. So we try to do things as quickly as we can just to give the illusion of being instant. And then it gets better. There are things called server-side languages, where basically you guys have all written a program for some class at some point because it's required here. And even the people that are in 110 now, which is probably some of you, I'm sure, I know you've started doing programming with real code because I was there. I kind of snuck into your class and sat in the back and watched that lecture. It was actually kind of fun. But there are these things called server-side languages, which is basically, it's a language, a programming language, that is, the language features are designed to let you do all these things. So there's a variable that just automatically gets initialized that is, here's where the person is coming from. And there's another variable that's automatically initialized, here are all their cookies. And here's what kind of browser they are. And here's what page they asked for. And then you do some stuff, and you tell it to print, and you print out HTML. But instead of printing out to the console like you did in class, it prints back to the browser. And then the browser will show it, and everyone's happy. And these languages are really powerful. So you can use them to access things like data on the server, or you can connect to a database, or you can connect to another server, or you could have it make a phone call and get some secret agents involved and kidnap someone's family. Anything you want to do. It's just a program. So programs can do whatever a computer can do, and then it just sends the results back to the browser. And then it gets even better. There are lots of web applications that are similar structure. Some of you may have heard of a blog. It's a pretty common thing. The idea behind a blog is one person writes content, and everyone else sees it. So that's pretty standard. There's some data, which is blog posts. Some users interact with it by reading it. A couple users interact with it by creating it. And then the changes get saved, like how many times it's been seen. There's comments. You can edit your posts. And people have started developing frameworks around this, which are basically, it's a software package that lets you take a language you already know, like Ruby, PHP-ish, if you already know that, Python, a bunch of other stuff. And it lets you just write a program, write a web application in sort of really high-level terms. You'll say, this is where the data goes, and this is what kind of data it is, and this is what it looks like when someone looks at it, and this is how it changes. And then you encode all these things as a program, and you press run, and it works. And it just generates all the HTML and style stuff magically. And you really don't have to touch it. It's pretty neat. So, quick summary. Web app is just a bunch of interactive web pages that let someone interact with data in some way. They're basically glorified text documents. HTML is just text. It's something that you could read if you really want. In most browsers, if you hit Control-U or View Source, you can actually see the HTML behind a page. And programs can generate that HTML automatically every time a request comes in and have it be a different, unique page for everyone that views it. And if you want to find out more, HTML, CSS, and design, if you have never done any of this before, Ryan will be teaching HTML and CSS tomorrow. Is Chris here? OK. Chris will be teaching just an introduction to design. So if you come tomorrow night and sit here for 3 hours or so, you can learn to make a very pretty web app. If you come back the next night and want even more of us, we're talking about JavaScript and PHP. So making your application interactive on the client side and then interactive on the server side. And basically, if you can sit through this stuff, you can write a web app. If you like listening to me talk, I'm doing the PHP lecture. If you don't like listening to me talk, you can look stuff up on the internet. I won't be offended. And then try the internet. All this stuff is really well documented. There's information everywhere. There's tutorials everywhere. People that learn this stuff really like writing tutorials, so there's hundreds and hundreds of tutorials on how to do the basic stuff. All you have to do is just Google it. Or you can Google funny cat pictures. So that's all I have. Go do something cool with the stuff that I've talked about. Go look stuff up. Go look up funny cat pictures. And any questions?
Do you like cats?
No, actually, I'm a dog person. but the internet likes cats, so it's kind of hard to. Yeah. All right. If nobody has anything, then thank you.
So Craig Younkins, he's an ex-Google intern, and he'll be giving a short talk on Google App Engine and DotCloud.
Yes. Yeah, so as Ryan said, I'm going to be talking more generally actually about deploying your web application. We're going to talk about some of the different options that we have, and then we're going to dive into App Engine specifically and a new service called DotCloud. So what are we going to cover? Why you should care. You guys are doing a hackathon. You're going to be building something in 24 hours. There's going to be a lot of pressure. Why should you really care about how you're going to deploy it? Well, first off, when you get up to present, you don't want to have to say, oh, you guys can't use it yet because it's on my local machine. It's fun to have interactive demos for hackathon demos. And so we're going to cover the options. And we're going to look specifically at platform as a service, and under those, DotCloud and App Engine. Cool, so why you should care. Touched on this already a little bit, but I've been through hackathons, and a lot of the projects that you start there, some of you will continue on, and they'll continue and grow. Now, if you choose something that is not ideal for that growth, and just something that you know that's really easy to do, you're going to hit problems later down the road. We know this all too well. So this is why it's important to at least think about these things before you start. Later down the road, you can change anything in software. You can rewrite the entire thing. It's about the pain that you're going to go through in order to do that. You also have to weigh that with the cost of learning something new right now. Most of the tools that I'm going to talk about today are super simple, and I think they would really accelerate even development on the day of the hack. So you made this shiny new web application, and you want to share it with the world. I'm talking about the little arrow in the middle. So as you would imagine, there are a number of solutions for this, and each one comes with its benefits and trade-offs. So you could buy a server. This would involve buying the hardware. You can purchase it from like Dell or something. You can have it shipped to your house. You can take it to a data center. You can rent space in a data center, put your server in there. All right, cool. Don't do this. I'm sure you guys, no one was actually thinking about doing this, but I figure I should mention it as a start. Servers are expensive. It might go down. You have no redundancy. You have to rent space in a data center, etc. So one of the more common options is a VPS, a virtual private server. So what this is it's a virtual machine hosted on a server in a data center. So a company, Amazon, Linode, something like this, we'll get into specifics in a minute. They have a number of physical machines that they have in the data center, and they install virtualization software on it. As a customer, you get a full virtual machine to access. You can install any operating system that you, virtually any operating system that you want. Then you have root on that virtual machine. You can install any packages, etc. So there's no worrying about hardware, but at the cost of that you don't get to choose hardware. Now, for most applications today, that doesn't really matter, right? We've abstracted above the layer of hardware. So you don't really care what brand CPU your application runs on. It doesn't matter. So you can choose the OS, but on the other hand, you have to install it, and you have to maintain it. You can install any software, but you have to install any software. So if you don't know how to set something up, you have to read the manual, etc. And it really slows down just development time. So if I need to install something like Apache, if I don't know already how to install Apache and configure Apache, which is non-trivial, I'm going to have to learn to do all this even before I start coding my application, which is what's really fun. So overall, you get some pretty fine-grained control, but it isn't as easy as it could be, and you lose some automated deployment stuff, which we'll talk about in a minute. As far as virtual VPS providers, there's some of the big names are Linode, Amazon, and Rackspace. These are just 3. There are tons of them out there. For the most part, they're very similar. We have starting costs here. Amazon is nice in that it starts free. I also want to focus in on EC2 because of what we're going to talk about a little bit later. But Amazon has their Amazon Web Services. And that's an umbrella over all of their web services things. Inside, they have tons of acronyms like EC2, S3, SMS, tons of things. EC2 is the Elastic Compute Cloud. So that allows you to query and say, I want a virtual machine of this size. You get it back, you can SSH to it, your root, etc. AWS, which is Amazon Web Services, internal traffic is free. This is really cool because we've been seeing companies that are now launching their business basically inside Amazon's data centers. So they're internal to EC2. So they're selling directly to customers who are also in EC2. They're providing things like databases, hosted database solutions, and other things. So, or for example, an image manipulation company. So you can do push images and get images back and forth, and you don't have to pay for that bandwidth. So, all right, let's run with the scenario of virtual private server. All right, you got to figure out what OS you want. All right, there's 8 or so very common Linux distributions, assuming you're going to run Linux, which I assume you are. So you have experience with Ubuntu. All right, you could run like Ubuntu Server or Debian, which is what Ubuntu is based off of. Debian is generally recommended for servers more so. So all right, let's go with Debian. So stable and testing. Debian has 2 different flavors. Well, they actually have more than 2. But there's testing, stable, and unstable. Given the name, you probably don't want to choose unstable. So testing and stable. Well, stable has stable packages. They're been around. They're well moderated. And they go through security review and everything's stable. If you launch an application on that, you can update packages in 2 years, and you'll be fine. But that means that a lot of packages get stale, old. So if I want to run my app in Python 2.7, and the latest version of Debian only has 2.5, I don't know that for sure. I don't think that's true. But as an example, then you're kind of screwed. So a lot of people go with testing. For that reason, testing is updated much more frequently. But there's always a catch, and packages in testing aren't verified by the security team. Yeah. So you're running Linux software. It hasn't passed through the Debian security team. You're kind of trusting that the application developer, or whatever server or whatever, has taken proper security precautions. It's kind of a risk. Probably going to have to read the manual because you have to configure Debian. If you've never used Debian before, you're going to have to mess with sources and etc. So need a web server too. 2 of the big names are Nginx and Apache. Apache is larger. It's been around for a longer time. So a lot of people choose to go with that. It's a big package. It's big software. It requires pretty significant configuration. So At this point, you might be wondering, well, what about Nginx? You have to make these decisions on what's going in your stack. Probably going to have to read the manual on that one. You definitely will for Apache. And you got to update your sources file. Let's say if you want like recent version of MongoDB, it's not in the operating system packaging system, so you got to add your own repository, etc. So all this stuff. So luckily, there's a better solution that's come around in the last year, 2 years, and that's something called Platform as a Service. And that's what I'm mainly talking about today. So instead of trying to explain exactly what Platform as a Service is myself, I'm going to let the founder of DotCloud, which is one of the Platform as a Service providers, explain it for me. Assuming I have any audio.
Hi, I'm Solomon Heiss. I'm the founder of DotCloud. We're making it incredibly simple for you to build and deploy your application in the cloud. All I have to do is write a little file that describes exactly the stack I need. That could be any combination of language, database, and middleware. It doesn't matter if you like Java, PHP, or Python better. If you like MongoDB or MySQL, we have it all. Once that's done, I simply run the DotCloud push, and my code will be uploaded to the platform, automatically configured and deployed, so that in a few seconds, my entire application is up and running in the cloud. It just works. DotCloud is the most sophisticated platform in the industry. For the first time, every component in your application can be run seamlessly across multiple data centers. So you can go back to coding, knowing that your application is available, can scale, and it's always up to date. You can create an account and start deploying for free. And we've got great documentation and tutorials for your favorite stack. So give it a try.
Yeah, so a little campy at the end there, but the basic idea is there. So Platform as a Service providers, they host applications, not virtual machines. So this is a little bit of a weird concept. I know when I first heard about it, I was still fuzzy. If there's any questions, by the way, please let me know. Are there any so far? Cool. So these Platform as a Service providers, they provide an abstraction for an application's dependencies, like the runtime environment, the database, et cetera. So you don't have to worry about installing software or configuring it for the most part. They handle it for you. So with this kind of nice environment, you get some constraints. So there's some constraints on what software can be used depending on what platform you're using. There's other things. So basically, your application is compressed into this image. And this image can go out to a server and be deployed. So this has some implications because, and so if that server dies because the power supply was pulled out or something like that, then your job, your application will get rescheduled onto another machine. So it provides a lot of the stability and reliability for free. What that also means is that your application could potentially die at any minute, so you don't have things like a local file system. Or if you do, you have to use it as kind of swap temporary space. It's non-persistent. So you don't have to worry about hardware. You don't have a choice about hardware. This is just the same as when you were running a virtual machine. But as we said, it doesn't really matter. You don't have to worry about an operating system. It's kind of interesting. You don't worry about the operating system that your server runs. You also don't have a choice on the operating system. So if you want to run, Gentoo, you can't. Who cares? Who likes Gentoo? So you don't need to upgrade or configure software. It's pretty nice. The admins at these service providers handle it for you. In many cases, there's limitations on what software you can actually install, though. So it depends on what you need. And as I was discussing, there's automated deployment and failover. So as in that demo, it actually is that easy to deploy an application. It's quite impressive. So there's three big players that I'm going to touch on. There's App Engine, Heroku, and DotCloud. So all of these can start for free, which is what's really nice for the hackathon. Who wants to buy a $20 server for a month when you're only hacking for one day? Obviously, there are differences between them. Google App Engine has more limitations than the other ones on what languages you can use. You can use Python, Java, and Go. Go is currently an experimental, and most people don't code in Go. But it's a cool language, so you should try it. App Engine has great reliability. Over the past year, their data store, which is their version of the database, had 0% downtime, literally 0, which is very, very impressive. There's capabilities for automatic scaling, which is cool. Basically, you set what threshold for response time you need. And if needed, the scheduler will schedule more instances of your application automatically. So if your hack on, what is it, Saturday?
Friday and Saturday.
OK. So if your hack gets really popular, you post it to Reddit, and your server gets swamped. If you're using something like a VPS, your server is just going to die. And with these, you can scale up pretty easily. App Engine also has this really nice development environment. So if you want to do web development, and in the typical way, you would install like Apache or Nginx in a local environment. You'd install a database, this stuff for your development environment. App Engine comes with a really cool development package that allows you to basically run everything that is run in Google data centers on your desktop. So you can run the entire web server, and you can run data store, and there are mocked APIs. It's pretty cool, and not something I've seen with anything else. Unfortunately, because of the infrastructure, there's really no good SSL solutions. So if you're developing something that requires secure data transfer, probably not your right choice right now. Then there's Heroku, which is pretty well known in the Ruby world. How many people in here want to code in Ruby on Friday and Saturday? OK, cool. It's OK. It's OK. So it was originally for Ruby. In my opinion, the documentation for other things is kind of lacking. But it's very comparable to DotCloud in the demo, in that you can write your application and do Heroku push, and it's up there. You get a URL, and it's magic. Heroku and DotCloud are both hosted in EC2. So this is where the EC2-based companies come in. So if you want to do any database beyond Postgres in Heroku, you have to get it through some other provider. So there are providers that do Mongo in EC2 and things like this. And Heroku has pretty good integration with it, but it's not as easy as it could be. That brings me to DotCloud. So I actually learned about DotCloud like a week ago. And as Ryan will attest to, I haven't really stopped talking about it. It's really cool. So it has a much more flexible stack than Heroku. You can use Java, Python, Ruby, PHP, Node.js, whatever. And that's just for the application layer. You can basically launch any database that you want. If you want Redis, Postgres, Mongo, Memcache, whatever. You can install it or have it be deployed. Students and startups get a free pro account, which is awesome. It's a value of $100 a month. So I'll talk about that in a minute, but that's really beneficial if you're looking to build an application really quickly. And DotCloud also has this really cool customizable thing where you can install arbitrary Ubuntu packages. So the servers run Ubuntu server, Lucid, the latest stable version. And you can actually configure it to, in the build phase, when it's compiling this image that's shipped around to different servers, you can tell it to install extra Ubuntu packages. That's not something that you get with any other provider, to my knowledge. So let's dive a little bit deeper into DotCloud. So as I said, it has really flexible stack configurations. You get SSH access, which is really cool. You can actually SSH to the running machine that's hosting your app. And you can see the local file system, things like this. It's isolated. You're in, it's called a cheroot jail. But, so you don't have full control over the system. You don't have root. But it's cool that you can go through and see your entire application there. And if you need to debug something, it makes it a lot easier. If you're interested in using DotCloud, I recommend that you sign up today and apply for a pro account. Getting a free pro account requires submitting a ticket to their help desk. Usually they get back to you within 24 hours. So if you want it by Friday, I'd do it today, just to make sure that you have it. So you can go there, go to their website, dotcloud.com, and do the contact form. So scaling. Primary accounting is based on services. So if you have a Python web server, or your application is written in Python, and it's served by the Python interpreter, that counts as one service. If you're running Postgres or Mongo or some other database, that counts as one service, etc. So primary accounting is based on services. One downside is that it's difficult to combine services. So one thing that's typically done is on your application server, you'll also run something like a memcache or a Redis server. And what that does is it provides a caching solution. So instead of hitting an external API or hitting the database, you hit the in-memory cache. So unfortunately, that's not possible with DotCloud, and you have to run a separate memcache server. Bear in mind that the connection over getting that data from memcache is probably faster than hitting an API or hitting disk in particular. So even caching large database queries is very useful. But the point of this is that you can't easily combine those two services into one image. They're separate things. Secondary accounting for this is based on the type of service. So for applications, you can spawn up additional service processes for $40 a month. That's to handle your extra incoming requests. And for databases, you can get extra space and RAM. You can also spawn more instances if you're using a database that is easily spanned across multiple machines. So Mongo does this, but SQL servers really don't. So anyway, we can talk more about that if you want. Let's talk about App Engine. So as I said, you can develop your application in Python, Java, and Go. The SDK provides local database and mocked APIs, which is really cool. Inside their environment, they have a number of services or APIs that you can use, very similar to what Amazon's cloud is like. So they have a database called the data store. They have an authentication service A blob store is something where you store large binary blobs of data. So this would be similar to Amazon's S3 as a place to store large files. You can do email, image manipulation, memcache, task queue, which is really cool. Shameless architecture plug. If you want to use, you should probably use task queues somewhere in your architecture to do asynchronous processing of whatever it is you're doing. So if you're sending an email, like as fast as it can be, you don't want to do that in the time of the request to the server from the client. You really want to say, OK, I'll do that in a second. And you put that in a task queue. Anyway. So a little bit more about the data store, because most applications run a database. It's a highly reliable and scalable document-oriented database. Blech. So there's two big types of databases. There's SQL type as relational, and there's non-relational object or document-oriented databases. So in the first class, you have MySQL and Postgres and things that you would typically use a SQL query for, select star from table name, where, etc. Document-oriented databases are becoming a bit more popular these days, partially because they scale really well. But they store documents as blobs instead of rows. So more about the data store. It's a document-oriented database. So it has something called GQL, which is a SQL-like query language, but it's not very commonly used and is usually interfaced with a programmatic interface. And that GQL language does not support joins, which is something that a lot of people find frustrating. But this is part of a larger change towards document-oriented databases, and it just requires a slightly different conceptual model about how you organize data in your application. You can use references and things like this, but you can't do joins. Another silly thing that it can't do is inequality filters on more than one property. So for scaling, as far as the database is concerned, which is one of the hardest things to scale, you don't have to worry about it at all. It's a service. You don't worry about its uptime. You don't worry about how many requests you're sending it. Google handles it. So you can think of it as any other API. You don't control it. You just use it, and it works. So Google has this like request router and scheduler, which handles your application code. So it's always monitoring. It's seeing how long does your application take to respond to a request? How long does it take for a server to become available to handle your request? So if you have two requests that come in a microsecond from each other, and the first one's still being processed, the second one's going to block and wait for a server to be able to handle that request. It's monitoring all that. And you have a configurable latency that you can tweak to say, like, if it's waiting more than 5 milliseconds to have a server respond to the request, spawn up more instances. And like magic, it'll go out and spawn more instances of your application, connect them to the scheduler, and requests will start being routed there. One thing to keep in mind with systems like this is that there is a startup cost to launching a new instance. It also affects your costs. So how many people want to write something in Python? Yes? All right, cool. I'm a big fan of Python web applications. So the biggest one is Django. Unfortunately, Django was designed for a relational database and really doesn't migrate well to non-relational databases, like the data store. So there are solutions to run Django on App Engine, but it's not really recommended. Pyramid is the second largest web framework. It used to be called Pylons. This one too, although it's more flexible and will probably integrate much more easily with App Engine, it still requires some silly patching. There's Web App 2. What happened to Web App 1? It's a good question. Web App 1, just called Web App, is a small framework maintained by Google. And it's very simple. It's what's called a micro framework. Provides you some basic things like request routing. It's not as full-featured as something like Web App 2, which is what a lot of people are moving towards. Provides a lot of functionality in terms of sessions, etc. For Java, I don't know, who gives a crap. So, I hope you guys decide to use a platform as a service for your hack. I think it would be really useful and allows you to get started really quickly. Other notes, like don't write code that you don't have to. You only have 24 hours, and at 3 a.m. you're going to be frustrated with your designer who thinks that it should be one way and you think it should be another way. So you really don't have time to waste. So leverage all the tools, APIs, and services that you can. If you have any questions for me, I can take them now. You can also email me, Younkins@gmail. Are there any questions? Yeah. Yeah, so it's kind of out of the scope of this talk, but I'd be happy to talk about it. So the question was about relational databases versus non-relational or document-oriented databases. So in relational databases, you typically store things in rows. You can access independent columns of the rows, and it's stored on the server in a row-like structure. So this is different from document-oriented databases where the documents are stored in blobs and are of arbitrary configuration. So for example, in Mongo, or arbitrary structure, I should say. In Mongo, you can have an arbitrary JSON object. JSON is JavaScript object notation. And you can have this power of, you can have lists, and you can have dictionaries, and you can have integers and strings. You can have these things in your document. Whereas, you can't have something like lists or dictionaries in a relational database without going through an additional layer or converting it to binary. Does that give an adequate explanation? Any other questions? Okay. Well, I'll be sticking around for a little bit longer, but thank you guys.